Alright, so today we're going to look at Kirchhoff's voltage law. Now, this was found by Gustav Kirchhoff in 1845, and it states that the sum of the voltages around a loop will equal to 0 if you pay attention to the signs, such as positive for voltage rises and negative voltage drops, which you could also write as sum of the voltage rises will equal the sum of the voltage drops. Now in DC circuits, this is pretty simple. Say our source is 12 volts and our resistor here drops 3 volts. So what's our voltage here going to be? Well, that's just going to be 12 volts minus 3 volts, which equals 9 volts. Now where it gets a bit trickier is when we start dealing with AC circuits. With AC circuits, we have to represent all of our voltages and currents in their complex form, whether that's in polar form or in rectangular. Now, if we want to convert between the two, we use these formulas here for polar or these for rectangular. Now here we have our AC circuit and we have our source voltage, a resistor, a capacitor and an inductor. We have our resistor voltage and our capacitor voltage, and we want to find the inductor voltage. So using Kirchhoff's voltage law, we can rearrange it to find the inductor voltage. We have the polar values here, and if we want to add and subtract, we want to convert those into rectangular form. We have our source voltage, which is just 50, and subtract from that 25 minus 25J, which is the resistor voltage here in rectangular form. And then we just subtract the capacitor voltage as well, which in this case will be negative 37.5. So this will be a plus, and the J value was also a negative 37.5, so that's also a plus. And if we sum all that up, that comes to 62.44 plus 62.44 J volts. And then if we want to represent this back into polar form, we use our formulas here, and that comes out to 88.3 with an angle of 45 degrees. For a more graphical representation, you can also take your voltages and plot them to scale on a piece of paper, and what you'll find is the resulting voltage will be your source voltage, which verifies Kirchhoff's voltage law. Thank you for watching, and I hope you found this video helpful.